All right, today's objective is to dilate a figure on a coordinate plane. This is going to be the fourth and final type of transformation we are going to talk about in this unit before we start reviewing for our chapter test. Okay, I can dilate a figure on a coordinate plane. Remember, this is an Edpuzzle, so you are able to pause this video at any time if I'm going too quickly, or you could rewatch it at any point if you like as well. And make sure we are taking notes. I'll be checking notes on the following school day in addition to the Big Ideas math that is for homework today. You will also have a skill check on the following day so that I know whether or not you understood the content. So make sure you're paying attention, attentively taking notes. And then if you have any questions, you can ask myself the following day. So why don't you, after you fill out the I can statement, complete the on your own review problems. Why don't you multiply the following expressions out? All right. A dilation is a type of transformation in which a figure is made larger or smaller with respect to a point called the center of dilation. So the key word here is larger or smaller. So it's saying, did my figure get bigger? Did my figure get larger? That's how you know it's a dilation or not. So let's take a look. Tell whether the blue figure is a dilation of the red figure. So if I were to go from blue to red, did my figure get bigger or smaller? Yes, it did. So that's how you know it is a dilation. It got bigger. Letter B, is that a dilation? Did it get bigger or smaller? No, it just slid, right? Remember, what type of transformation is that called? This is called a translation, right? It just slid. So for it to be a dilation, it has to get bigger or smaller. It can't just stay exactly the same size. So using that information, why don't you do 1 and 2 and explain your reasoning as well. Okay, in a dilation, the original figure and its image are similar, not congruent. Why? Because the sizes, the corresponding sides are larger or smaller. The ratio of the side lengths of the image to the corresponding side lengths of the original figure is the scale factor of the dilation. Okay, so remember, our objective today is to dilate figures in a coordinate plane. To dilate a figure with respect to the origin, all you are going to do is multiply the coordinates, so both coordinates of each vertex, by the scale factor k. So if I have x comma y, you'll be multiplying both x and y by k. Let's say the number k is larger than 1. This is called an enlargement because it is getting larger. If it's less than 1, then it is called a reduction because it's getting smaller. So enlargement is bigger. Reduction is smaller. So that's how you can figure out if it is an enlargement or reduction. So if k is bigger than 1, enlargement, less than 1, reduction. Okay, so let's do this. Example number 2, draw the image of triangle ABC after dilations with scale factor of 3. Identify the type of dilation. So let's plot these points first. A would be 1, 3. B would be 2, 3. C would be 2, 1. Here is my triangle right there. So I'm going to multiply by a scale factor of 3 because 3 is bigger than 1. It should be a bigger image. So let's just double check if it is. Oops, sorry about that. So remember, I'm going to multiply each term or each coordinate by 3. So A prime would be 3, 9. B prime would be 6, 9. C prime would be 6, 3. All right, so now let's plot these points and see if I get it correct. So 3, 9 would be right here. 6, 9 would be right here. And 6, 3 would be right here. Did it get larger? Yes, it did. And because it got larger, this is what we call an enlargement. All right, so why don't you do on your own number 3. All right, let's do a final example. Draw the image of a rectangle of the following WXYZ after a dilation with a scale factor of 0.5. Identify the type of dilation. All right, so let me plot these points. -4, -6 would be around right here. Negative 4 comma 8. 4 comma 8. Oops, I think that's at 3. There we go. And 4 comma negative 6. So here is my original rectangle. So scale factor is 0.5. This is less than 0. It should technically get smaller, or this is called a reduction. Let's double check our math to see if that works. So I'm going to multiply each term, this, multiply by 0.5. Multiply by 0.5 is the same thing as cutting it in half, right? You're dividing each by 2 essentially. So I don't know why I keep doing that. W prime would then be negative 2, negative 3. X prime would be negative 2 comma 4. Y prime would be 2 comma 4. And Z prime would be 2 comma negative 3. All right, let's plot these points and see if our prediction was correct. So negative 2, negative 3 would be right here. Negative 2 comma 4, 2 comma 4, and 2 negative 3. This is my final image, and it did get smaller, so it was reduced. So why don't you fill out your level of understanding? How do you feel after this lesson? If you need to rewatch any portion of the video, you are free to do so. If not, you may go ahead and get started on the homework. If you have any questions, you can message me on Schoology or wait until the next school day and I'll go over it then. Bye, everyone.